Today, we're back with Unintended Consequences, Episode 50. It's July 6th, 2026, Monday, a fresh case to chew on as the week begins. In the spring of 2003, a mid-level NIST engineer named William Burr finished a 57-page document that would shape logins for the next 14 years. That document laid out a precise set of requirements for what counted as an acceptable password on federal systems. It called for passwords that mixed uppercase letters, lowercase letters, numbers, and at least one special character, while also requiring every account to be changed on a fixed 90-day cycle. The arithmetic behind the rule was straightforward on paper. Each added character class was meant to multiply the number of possible combinations an attacker would have to test, pushing the total search space well beyond what brute force tools could cover in a reasonable time. The guideline told every federal agency and soon after most corporations to require passwords with uppercase letters, lowercase letters, numbers, and at least one special character, plus a forced change every 90 days. The stated goal was simple: raise the theoretical entropy of each credential so that brute force attacks would become impractical. Instead, the rule set produced a generation of passwords that looked random on paper but followed a handful of human shortcuts that attackers quickly cataloged and automated. What the drafters had not fully modeled was how people would actually behave once they had to satisfy 4 separate constraints every quarter. William Burr and his colleagues at the National Institute of Standards and Technology were responding to the visible failures of the late 1990s and early 2000s. Corporate networks were being compromised through weak or reused passwords, and incident reports from banks and government contractors showed that attackers often succeeded with simple dictionary words or slight variations. At the time, the dominant threat model treated the attacker as a machine performing exhaustive search. Increasing length and character variety was the mathematically obvious countermeasure. The team drew on established information theory concepts and on earlier military password practices that already mixed character classes. No one on the drafting committee claimed the rules would be pleasant for users. They assumed that disciplined personnel could be trained to comply and that the added entropy would outweigh the friction. NIST Special Publication 863, released in 2003, embedded the requirements for federal systems and was rapidly adopted by Microsoft Active Directory defaults, corporate policies, and university IT departments worldwide. Vendors marketed compliance as a selling point, and auditors began checking for the presence of complexity flags and 90-day expiration settings. Early metrics looked favorable. Password cracking contests run on internal red team exercises showed longer times to success when the new rules were enforced. A few skeptics inside large banks and at Usenix conferences noted that users were writing passwords on sticky notes or storing them in spreadsheets. Those observations remained anecdotal and were dismissed as training problems rather than design flaws. Once the rules spread, users faced a memory problem that the threat model had not addressed. Faced with creating a new 12-character string every quarter that satisfied 4-character class rules, most people converged on a small set of strategies. The most common pattern was to take a familiar base word, capitalize the first letter, append a number, and tack on an exclamation point or other symbol at the end. Lists recovered from the 2009 RockU breach and later dumps showed password 1 exclamation point and close variants appearing hundreds of thousands of times. Because the same transformation was applied across multiple accounts, a single compromised password often unlocked email, banking, and corporate VPNs. Attack tools incorporated these observed regularities into rule-based guessing engines, so the theoretical entropy advantage disappeared in practice. Help desk tickets for forgotten passwords rose sharply, prompting many organizations to relax reset procedures or to allow password reuse within a short window. The 90-day rotation rule added another loop. Users who could not remember 12 new strings per year simply incremented the number at the end or cycled between 2 passwords they could retain. Over time, the visible security ritual created a false sense of protection, while actual credential databases grew more predictable to automated attackers. By 2016, internal NIST reviews and independent studies had accumulated enough breach telemetry to show that forced complexity and rotation were not delivering measurable reductions in account takeovers. In 2017, NIST released SP 863 3, which removed mandatory character class rules and eliminated forced periodic changes for most accounts. The new guidance instead recommended long passphrases that users could remember. William Burr, by then retired, told the Wall Street Journal that he regretted the earlier advice and wished the document had placed greater weight on human behavior. Some organizations adopted the new guidance quickly. Others retained the old policies because auditors still scored them as stronger. The reversal itself produced a secondary effect. Many employees who had spent years memorizing complex strings now had to be retrained to stop using them. When a rule optimizes a single measurable proxy, such as entropy per character, it can degrade the larger system once humans adapt inside the constraint. Security policies that treat users as reliable executors of complex procedures tend to generate workarounds that attackers can observe and codify faster than the procedures can be updated. The durable safeguard is therefore to design the rule set around the behavior that will actually occur rather than the behavior that compliance language assumes. The same pattern appears today in multi-factor authentication fatigue prompts and in lengthy cookie consent flows. Each added step changes what people do, not merely what they are told to do. When you next face a new verification screen that assumes perfect compliance, what adaptation might already be forming on the other side of that prompt? And that's where today's story leaves us. If it changed how you see one everyday decision, that's the whole point. Pass it along to someone who'd appreciate it, and we'll be back tomorrow with another case. And if you'd rather watch than listen, find us on YouTube at NARA Network. Links in the show notes. And before you go, this show is part of the NARA Network, a family of daily podcasts on tech, science, and markets, each one a short, sharp briefing you can finish on the commute. If today earned its place in your feed, here's your next listen. Fascinating Frontiers, the most fascinating news from space and science. Find every show free at naranetwork.com. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.